so you know, I'm okay with it. I'm not going to hold you hostage. So, modeling and equation solving. We're going to kind of go through some stuff that's going to seem really simple. Why would I do this in precalculus? And then we're also going to remind ourselves how to solve a few different types of equations today that we haven't seen. So, most things that we do in math, you can display three ways. Think about linear equations for one thing. Back in the day, when you first start learning about equations, you set them up in a table. Usually we think of an XY chart. I always tell students, if you forget how to graph something, no matter what it is, you always can go back to that XY chart. You can pick values for X, you can plug it in, and you can always get those Y values, get some points on your graph, and hopefully get the right shape there. We can also use a graph. Again, we have those graphs that we should know. We should know what a linear graph looks like. Maybe we should know what absolute value graph looks like. Maybe we should know what a quadratic looks like. Quite a few different graphs that we've learned about. And then probably the way that we think about the most is an equation. Most people would prefer to deal with an equation over a graph or a table, but all three of those are ways of representing data, and we'll be doing that all three ways. Okay? So that's kind of all that's there. So we're just going to jump in here to a little problem here. You don't have to write every word of this. Maybe just the important information. But it says a pizzeria sells a rectangular 20-inch by 22-inch pizza for the same price as its large round pizza that is 24 inches in diameter. So we have a rectangular 20 by 20 pizza and a round 24-inch diameter pizza. If you only wrote down those things I underlined, maybe the word pizza, maybe, not necessary really. If both pizzas are the same thickness, which option gives you the most pizza for the money? And maybe you would just order the pizza based on whether you like rectangular pizza or circular pizza. Pizza King. Little Caesars, back in the day, Little Caesars had a rectangular pizza. Really long, giant pizza. That's probably when you were like 4. A rectangle, a square is a rectangle. Okay. DiGiorno's. Doesn't, whatever is down the road, Chicago's has a rectangular pizza. We get that one. It's a really big rectangle. And maybe you wouldn't think this, and I always like to show this one because really there's some math involved here. And we can figure out which pizza, if they're the same price, which pizza gives you the most pizza for the money. So, rectangular pizza is 20 inches by 22 inches, so I'm going to make this 22 by 20, just since that side looks longer. And if I wanted to find how much pizza was there, what am I going to find there? The area, right? Like, we don't think about pizza in area very much, but we want to know how much pizza is there. So how would I find the area of this rectangle? Length times width. So that would just be 20 inches times 22 inches. And you can do that. I think it works out to be 440 square inches, right? If we're talking about area here. 440 square inches of pizza. That seems like a lot of pizza. Pretty big rectangle. Like. But yeah, we get them here when they buy pizza for us. They're pretty big. They usually order like one per lunch shift. And let me tell you, that's a lot of pizza. And most people feel bad. Well, not Mr. Mueller's never felt bad. He would take like 8 pizzas. But most other people would be like, I'll take 2 pieces if you don't want to have a pig and take like 4 pieces. What's that?
Some night we going back home, stop at Green Castle and go to Humble Pop. Order pizza there, take it home.
How do you find the area of a circular pizza as a 24-inch diameter? So that means all the way across, right, is 24 inches. 1/2 r squared. What you said? Area of a circle. Anybody? I don't think that's right. Anybody remember area of a circle? pi r squared. Remember, pi comes from circles. So, do I plug 24 in here for r? Right, that's the radius, this is the diameter. So I'm going to plug 12 in there, and that's 144 pi. You can do that on your calculator. I got 452.16, if I'm rounding, square inches of pizza. Is that right? My husband and I are looking for a new house right now, hopefully to live closer. And I just want to live somewhere I can get pizza delivered to my house, because I've never, except for when I lived at college on campus, I've never lived where I could get pizza delivered to my house. I know, but wouldn't it be so nice to have pizza delivered to your house?
Where I live,
Or Jimmy John's. If you live near Jimmy John's, there's a original orders.
they'll deliver it to the Madison Township Fire.
Oh, I don't think that's right. Sorry, say that again, Logan. I wasn't listening. I got 452.39 when I used my pi button. Did you get that? I think maybe I just used 3.14. Yeah. If you just use 3.14, then you get the 452.16. Whatever. Either way, it's still more pizza. Do you agree with that?
Yeah.
So which option gives you the most pizza for the money? The circular pizza, the round
Which I
pizza.
kind of debate.
You don't think so?
I don't know.
You would think I think the rectangular pizza, you probably would get more pieces, right? Like you could cut that up into more pieces, but they'd be smaller pieces. But you'd get more pizza for your money. Maybe you got to think a crust to pizza ratio. Which would you like? Which would have more crust? I think there's a lot that goes into it. But if you're just talking about the most pizza for your money, the round pizza. So just so you know, you might have to do some math next time you're at a pizza place.
But what's the likely odds that they make the exact same price?
At a math pizza place, they would be, and they'd make you figure it out. It should be like a place in the mall that's all about math problems and makes you, like, they don't really give you what's the best option, they make you figure it out.
Figure it out one time, you're going to tell everybody.
You're going to tell everybody in the whole world.
No, I mean if they ask.
You need to quit hanging out with Logan so much. I feel like I could have put this on your quiz yesterday, and you could have done this. But again, since we're talking about solving equations, modeling equations, quadratics are one that we should know how to do. So if we're going to solve this algebraically, that means we have our three options, right? We can factor, or we can complete the square, or we can do the quadratic formula. Again, I don't care which way you do these problems, as long as you're doing them correctly. First thing I see is that it's not equal to 0, so I'm going to get equal to 0. And you might say, well, I'm going to subtract x squared over, because it's only one thing to subtract over, and it's fine, but I like to keep my x squared positive, so I'm never going to do that. I'm going to move the other stuff over this way, so I'm going to add 4x, and I'm going to subtract 8. And I don't think that's going to be factorable, right? Because there's nothing that multiplies to give you 8, that subtracts to give you 4. So quadratic formula or completing the square. I'm going to do completing the square on this one because I feel like it's a really easy one to do completing the square on, because there's nothing in front that you have to divide by. Another thing that makes completing the square nice, this is an even number, so I'm not going to get any fractions. If there was a number in front, or if this was an odd number, I probably would do the quadratic formula. And you have the choice to do whichever you want. I just like to make you think through what would be the easiest for me. So for me, completing the square is easier than the quadratic formula. So I'm going to add that 8 back over. And what number am I going to put here to make that a perfect square trinomial? 4, because half of 4 is 2, and 2 squared is 4. But if I add 4 to one side of the equation, I also have to add 4 to the other side, or otherwise I've changed the whole balance of the equation. And then I'm going to factor this. It's always going to be a perfect square, so that's why I can write it as something squared. And it's always going to be half of that middle number. Half of 4 is 2. I'm going to take the square root of both sides, and I'm going to get x plus 2 equals plus or minus the square root of 12. You're right, I don't want you to give me decimals here, but I do want you to simplify all the way. And when you see the square root of 12, you should know that you can break that up. That's the same as the square root of 4 times the square root of 3. So as I finish this up, I'm going to subtract 2 over, and I'm going to write this as plus or minus 2 square root of 3. You should get the same answer if you did the quadratic formula. Did you do the quadratic formula? Did you get that? Let me do the quadratic formula real quick. Negative b, so we'd have negative 4 plus or minus the square root of b squared, so that'd be 16 minus 4 times a times c all over 2 times a. I like to leave the square when I can do it because I don't have to worry about like arithmetic mistakes or simplifying mistakes. But you're right, most of this is just calculator. That's going to be a positive 32. So 32 plus 16, is that 48 under there? Did you get that, Square?
Yeah.
What can we take out of 48? 16? Does 16 go under 48? I always try to look for the biggest perfect square so I don't have to keep breaking it up. Like you might think 6 and 8, which is fine. But then you still have to break 8 up. Like there's still a lot of work there. So if you try to find the biggest number possible, it's less work. So 48 breaks up as 16 and 3. Remember, you could not at this step divide 2 into the square root of 48 because it's under square root. So you would get plus or minus 4 square root of 3 over 2. Then you can break it up into 2 separate fractions, or maybe you just see that you can divide 2 into both of these, and you are going to get negative 4 divided by 2 is negative 2, plus or minus 4 divided by 2, which is 2 with a square root of 3. Yes, sir?
Okay, now, instead it was like 12 on mine.
Uh-huh.
It was like, instead of 3, it was like 4.
Okay.
Break it down.
So you have negative 4 plus or minus 3 squared of 3 over 12.
Yeah.
You could, or you could leave it like that. Like if you left it like this, that's not wrong.
It's not?
It's not simplified.
Well, you can't factor anything out of the top. Do you agree with that? You could break it up, though. You could separate it into 2 different fractions and say negative 4 over 12 plus or minus 3 radical 3 over 12, and you would get negative 1/3 plus or minus radical 3 over 4. But because there's no common factor on the top, if you leave it as one big fraction, that's okay, or that's okay.
What if that 3 was a 2?
Oh my gosh. If that 3 was a 2, then you could simplify it more. Because if that 3 was a 2, I really have no power here right now. Oh, there we go. If this 3 was a 2, now there's a common factor on top. It's all about, is there something that you could factor out of the top? If that 3 was a 2, you could take a 2 out of this, and you'd be left with negative 2 plus or minus the square root of 3. And you could cancel that 2 with that 12. Like, it's all about, is there a common factor in the numerator, whether or not you can leave it as one big fraction. Does that make sense? Okay. That's really nothing to do with this. You didn't simplify it? That's not good. But if you did everything else right, that's just 1 point. I'm sorry. You guys see Sarah Woodworth later. I think these are... They do.
That's something I've always wondered. How do people forget their keys?
Well, she's not leaving. When she goes to leave for the day, I bet she'll wonder where they are.
These more notes.
These are more notes. Yep. I feel like if you were in my class last year in Algebra 2, I pushed this a lot. Like, I even think I put it on a couple different tests. the relationship between the words roots, zeros, and x-intercepts. You need to know that all of those mean the same thing. And so I think this is straight from your book, and it's up to you on if you're going to write it word for word. But it's really important that you know when you solve any equation, whether it's a quadratic, whether it's a linear equation, whether it's an absolute value equation, any type of equation, if you solve that, so they just write it as if you solve the equation f of x equals 0, you need to know that your solutions all mean the following things. So they're saying A is a number that solves this. So that means that your answer is a root or a solution. Those are interchangeable words of that function. And again, probably you could just write it is a root or a solution if you don't want to write the full sentence. We also say that that number is a zero of that function. Roots, solutions, zeros. They all mean what you get when you solve that problem. I could use those words interchangeably. I expect that you can use those words interchangeably. If it's a real number, now if the solution's imaginary, this is not true, but this says it's a real number, that means that it's also an x-intercept of the graph. And we're going to be doing a lot of graphing in this chapter. Anytime you solve an equation equal to 0, the numbers that you get are where it crosses the x-axis. So we call it a 0, because it's where y equals 0. Oh, I think that's it. I think last year on a test in Algebra 2, the question was, give me maybe I gave you solution, and I said, give me the other words that mean the same thing as solution, roots, zeros, x-intercepts. I could give you one, and I would expect that you could give me the other three that go with it. Right, so I hit that a lot last year in Algebra 2, and I'm going to talk about it again a lot here. It's very, very important. We did. It's very important. Can I go? People still writing? Here we go. Unless someone tells me to stop. This is in your book. I really think you should read your math book, and I know that you're just going to laugh at me when I say that, but your book makes me laugh sometimes because it says some really funny stuff. Maybe you don't think it's funny. But this guy, George Polya, who died in 1985, born in 1887, he lived a long life there, it says he is sometimes called the father of modern problem solving, not only because he was good at it, but also because he published a most famous analysis book called Problem Solving Process. Story problems. I know people hate story problems the most. Lots of people see a story problem and they don't even try it. Story problems are the applications. You ask all the time, when am I going to use this? How does this apply to real life? Those are story problems. You're going to be seeing a lot of story problems. You're going to see story problems on tests. And so it's important that you kind of know what to do. This is kind of a very vague plan. In your book on page 76 and 77, they kind of elaborate a lot. The big thing that I want to point out is understanding the problem, understanding what they give you, and what you're looking for is like the number one thing. Like on those, what did we just do? The throwing the object up in the air or whatever, launching the rocket. You got to know, what did they give me? Where do I plug it into the formula? And what am I looking for? Devise a plan means you got to figure out, am I going to graph it? Am I going to make an equation? Am I going to make a table? Am I going to guess and check? And then you obviously do that. And then this, I feel like, is the most important part of any problem-solving process. Whether you're doing a math problem or you're building a house, you got to look back and see if your answer makes sense. Sometimes I give story problems, and I say, like, the answer, when we start talking about finance and all this stuff, we'll be talking about like how much interest you would pay on a car, or what would be the total price you would pay for a house if the mortgage rate was blah 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 blah. And sometimes people give me like answers that make no sense for the problem. If the car costs $5,000 and the question asks you how much total would you pay if the interest is blah, 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 and your loan was for 4 years, the answer shouldn't be less than $5,000. It also shouldn't be like $5 million. And people give me those crazy answers all the time because they don't even look to see what the problem's asking and see if your answer makes sense. So that's one of the most important things that I could give you, especially as you go and take the PSAT or the SAT or the ACT. See which answer makes the most sense, especially on those multiple choice problems. And that can help you a long way in this process, okay? All right, let's do some more math here. Again, this section, because this is pre-calculus, they expect that you've seen this stuff before. That they don't have to break everything up as one section at a time. And in this section, we're only going to talk about linear equations. And then the next section, we're only going to talk about square root equations. They're going to throw lots of stuff in together because these are all functions, and these are all functions that you've dealt with before. But I just wanted to remind you how to solve this. Anybody have a suggestion of what I can do first to this problem? Yeah, we got to get rid of that square root. Just like with absolute value, you want to get it by itself first. Square root, you want to get it by itself, and it is by itself. But the only way that we can get rid of that is if we square it. And just like we can add 7 to both sides, we can also square both sides. And when you square this, remember that's not just 4x squared minus 25. You're actually going to, that's 2 of these, and you actually have to FOIL that out, right? So you would get 4x squared minus 10x minus 10x plus 25. And the great thing about the other side is when you take the square root of something squared, those are inverses, so you just get back x plus 4. And once you do that first step, it's now just a normal problem like I could have put on your quiz yesterday. That's a quadratic. How do I know it's a quadratic? Because there's an x squared in it, which means I'm probably going to want to get it equal to 0. And see if I can factor, complete the square, or do the quadratic formula. So I'm going to subtract x, and I'm going to subtract 4, and I get 4x squared minus 21x minus 21 plus 21. Yeah. Quadratic formula. Yeah. I definitely don't want to divide by 4. I could complete the square. If you multiply the first and the last, you're going to get 84. I don't even want to dealing with the factors with that. So this would be one I would use the quadratic formula on. Let's just see what. Oh, just skip it? Is that what you said? Okay. This class has a lot of problems that don't work out very nice, so we have to kind of get used to dealing with answers that don't work out very nice. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Well, it would be, but it's always going to be positive, so I kind of never even worry about putting that in there because I know that when I square it's always going to be positive. But you're right. Technically, if I was plugging it in, it would be negative. I'm just going to do that all at once under the radical because you can do that all at once on the calculator. 21 squared minus 4 times 21. And I think you get 105. Again, when you do a problem like this, you want to look to see if you can break up that square root, which means you're looking to see if perfect squares go into it. The nice thing about an odd number is that means 4 is not going to go into it, which means 8 is not going to go into it, right? 8 is not a perfect square. 16 is not going to go into it. I think 3 goes into it. 3 and 35, that doesn't get me anywhere. That's not perfect squares. So I feel pretty confident saying I can't break 105 down. Try a few perfect squares if you aren't sure. I can't break that down, which means I can't simplify that 8 with anything. So that's it. Like, I would just leave it like this. Or remember, you are allowed to break it up into 2 fractions if you want. But that doesn't simplify, so I would just leave it like that. Wait till we hear Selena playing over there. It's very exciting. You just hear the music, though. That's all we hear is the music. All right, can I go? Look, that's it. All right, so. All right, so here's your new assignment sheet. I would suggest putting this somewhere. I have your let's see, I have your homework up here. I'll pass back in just a second. But this is your assignment sheet. If you are absent, use your assignment sheet to get the next assignment. Also, you can go on Harmony or My Big Canvas and get the notes and the homework from that day. But it should pretty much follow this. I want you to open your book because people always get confused on 1 through 10. So I want you to open your book, kind of label your paper, and so we can talk about this. The first thing I gave you on the notes today is that you can display data through a table, through a graph, through an equation. So the first 10 problems, 1 through 10, they give you all 3 of those. So notice 1 through 10, they're all XY charts. Normally when we make XY charts, or at least when I make XY charts, I make them vertical. But this is also an XY chart, just the X is on the top and the Y is on the bottom. And there are 2 things you're supposed to match each of those up to. There are also 10 graphs. You see those labeled A through J? You're supposed to match each one of those XY charts up with which graph does it go with. Which means you have to think a little bit. Like looking at number 1, look at what's happening. 1, you can look and see what's happening. As X is getting bigger, what's happening to the Y? It gets bigger, which means your graph should be going up. That's going to eliminate a few options. You also should be able to look to see if it's a constant change. If it's changing the same every time, what kind of graph is that going to be? A straight line. So that's going to help you find the one that's a straight line. You see the ones that are like parabolas? You should be able to think what's happening. Like you should be able to kind of use a process of elimination. Something else that can help you. Maybe it would be easier. Look at letters K through T. You're also going to match each one of those charts with an equation that matches that chart. So could you, like, look at letter K, whichever chart you think maybe that one works with, could you plug some of those numbers in for X and see if you get the Y value that goes with it? You see what I'm saying? It's not going to be just and use your calculator to get a few of those. Alright, so you have some time today, like 10 minutes. I wanted you to have extra time today because I know people struggle with this